Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning to my viewers. So my name is HAZIQ JAMSARI. My metric number is 1899977. So today I would like to present about my final year project. So the title is Uncertainty Analysis of Different Models in Estimating Potential Evapotranspiration. So my supervisor for this project is Professor Madya Dr. Rowhson Kamal. Okay. Here is my presentation outline. So basically, this is what I will present for today's presentation. So for my introduction, actually, what I will be doing is about evapotranspiration, or it can be known as ET, where it's a process where water is transferred from the land to atmosphere by evaporation from the soil and other surfacings and transpiration from plants. So basically, ET have two terms. The first one is actually potential evapotranspiration, and the next one and second is actual evapotranspiration. For my study, what I will focus is on potential evapotranspiration, or we can call it as PET. So potential evapotranspiration is environmental demand for evapotranspiration, and actual evapotranspiration is water removed from the surface due to evaporation when there is rain and then and so on phenomena. So for potential evapotranspiration, for a better understanding, actually PET is the rate of transpiration from the green grass or short crop that shedding the ground from a uniform of height. So that is what I will estimate it along my study. So next is my problem statement. So there are 4 problem statements that I let me show. So the first one is PET actually crucial for determining the irrigation of water demand. The second is the change of the climate effect will affect the crop evapotranspiration. And the evapotranspiration is actually well known as the amount of water used by the crop. So foul permanent is actually well known for computing the ETO or the PET. However, because of the data that needed for the PET is not available in all the regions in Malaysia, so this study is actually to determine which simplified model that is suitable to compute the PET. Okay, so this is my literature review. So there are many research that have been made. So basically, these five research that I will show you. The first one is from Paparizos et al. In 2014. It stated that it is important as it stimulates hydrological effects, and the purpose for the study is to estimate the potential evapotranspiration under various climate. Next is from Y in 2004. They estimated the PET using 2 different equations, where Penman and Christianian, for choosing which is the best method to be used. And next is from Ahmad et al. On 2017. They compare the commonly used PET method, where the station in the country is only record air pressure and precipitation. This study has actually been made in Kashmir Valley in India. So next is Mohawesh in 2011. So the study of from Mohawesh is to assessing the performance of simpler model that needs less data than permanent. And lastly is from Surendran et al. In 2015. The purpose of the study for the assessment of water resource for sustainable water resource management. So basically, all the research that have been studied before this, the objective and the goal from the study is actually quite similar with what I have done, where I want to know which simplified model is suitable to be used in my country, in Malaysia, especially in Tanjung Karang. So for my aims and objective, the main aim of my study is to determine the most suitable equation to be used with the comparison of the reference equation 456 per Montet. And my specific objectives are, the first one is to calculate the potential evapotranspiration using the different empirical models. Next is to identify the suitable models by ranking to be used in the future to analyze the irrigation water demand. So lastly is to compare the best model with the rainfall distribution. Okay, so this is my methodology. So for my study site, the location is in Tanjung Karang, and the data that have been retrieved is from Subanjaya Airport, where I have retrieved maximum abnormal temperature, maximum abnormal relative humidity, wind speed, elevation, location of the study, and observed solar radiation. And I also received the rainfall data at Tanjung Karang. Okay, so next is, this is the equation for FAO 56 implemented. This equation, I use this equation as my reference equation, where this equation is actually the most well recognized equation to calculate the PET. So as you can see, the parameters needed is actually quite a lot, and the equation is quite complex to be used. So these are all the parameters needed. Now next is, this is all the empirical model that I've been selected. I have differentiated this empirical model into 3 different categories. The first category is mass transfer, next is radiation based, and the third one is the temperature based. So these different categories need different parameters. So for example, mass transfer only need winds, air temperature, winds, and wind speed for calculating the equation. Okay. So lastly, I will do the statistical analysis. Uh, I will using 5 indicators. First is R squared. R squared can be get from the Excel automatically. Next is NRMSE, PE, ME, and D. So for choosing the best equation, they have to satisfy these few conditions. The equation to be highest in value of R squared, smallest value in NRMSE, PE, and ME, and has to have the nearest value to 1 in D, where it is called index of agreement. So lastly, I will use the weighted score, where I will add all of the score that I've gained and time multiply with 1 over 22. And the lowest weighted score will be ranked as the best equation. Okay, here is my result and discussion. So this is for mass transfer categories. So for mass transfer categories, WMO ranked as first. So because of the consistency in weighted score, and you can see also because of the pattern of the PET itself, where the result of PET for WMO overlay with the result of PET with the reference equation, which is far mounted. Okay, and the result for R squared so actually satisfy the conditions where R squared to be the best equation, the value of R squared must be between 0.2 to 0.5 to be exact. Okay, next is radiation base. So for radiation base, I have concluded that modified remark will be ranked as first in these categories. But actually, you can see that in the graph, the result of PET actually quite underestimated with the reference equation. But because of the range of the PET, daily PET of the modified remark, so I'll conclude it as first equation in these categories, and also because of all the weighted score where it show inconsistency of the weighted score. So for temperature based, SARS-CoV ranked as first equation because of the shorter range in daily PET, and we can see that the range of the PET is quite low between the daily PET, and it has the highest score in D and PE as it shows 0 in D and smallest value in PE. Okay, so next is my daily estimation of PET. So when I compare all together with the 22 equation, I get this result where treble rank as first, WMO ranks as second, and the third one is modified remark. So actually, mass transfer equation actually has the better reading of PET. So next is what I do is I compare the ETO of the 3 battery model with the rank for distribution. So in this graph, there are 2 types of graph, the bar graph and the line graph. The line graph show the rainfall distribution, the bar graph show all the PET of the reference and the selected battery model. So from this graph, we can it shows that WMO shows the nearest range of PET with the reference equation. And to support my, so I can conclude that WMO is actually the best equation to be used. To support my discussion, Muhammad et al. In 2019, it indicates that mass transfer category is actually the most appropriate to be used in Malaysia. And so WMO is actually one of the mass transfer equation. So in the graph, you can see that for the black bar graph, is actually a reference equation, and the green is the WMO equation. You can see that the range is actually quite near, and when I compare with the rainfall distribution, it shows the quite similar result with the reference equation. Okay, let's say if I choose the blue one, where modified mark one. So in April, you can see in April, uh, reference equation for paymented indicates that I need this amount, this much of water to be for the water requirement of the crops. Same goes as WMO. But if I choose to modify mark, actually it will be a wrong planning for the farmers, because it indicates that I don't need the water to be supplied to the crops. And actually it's actually wrong, because from the reference it says that we need this much of water, and WMO also show the same thing. But if you use the modified mark, the crops cannot have the water that be needed. So the sustainability of the crops will not be obtained. So I think WMO is the best equation to be used for estimating the PET in the future. Okay, so as conclusion, for my conclusion, the first one, I has analyzed all the equations, all the PET of all the 22 empirical models, and Fabric ranked as the first for daily computation. And the worst equation is the bootcamp and winner. And lastly, what I can be conclude is WMO is considered to be the best equation to be used because of the comparison of monthly PET with the respect of the rainfall distribution that have been demonstrated in the earlier slide. So what I can recommend it for my study to be improvised is the first one. So I recommend to assess in other location using the local meteorological data, and I recommend to use more models to get a better alternative model beside file payment mounted. And what I can add from my recommendation is I have to obtain the same data of at the study site. I have to go to the study site and obtain the data by myself by using the apparatus that the apparatus that can measure all the weather data. So I think that's all for me. Thank you for lending your time. And assalamualaikum.